Hello everyone and welcome to Climate Conversations. I'm your host Kathy Yang and today we're going to be talking about thermohaline circulation. So thermohaline circulation has a nickname, the Great Ocean Conveyor Belt. And this makes sense because thermohaline circulation is a system that occurs in every single ocean and it's connected, creating what looks like a conveyor belt, and it's a cycle where water masses sink or rise. It's dependent on two factors, the first being temperature and the second being salinity, hence the name thermohaline. So as temperature is lowered or as salinity is increased, the density of a water mass will increase, causing it to sink downwards. This sinking process occurs near Greenland and also Antarctica, and it begins when sea ice is formed. So as sea ice is formed, it leaves behind a lot of salt in the ocean, therefore increasing the salinity of the water mass and allowing it to sink. So why is the thermohaline circulation so important and crucial? Well, it helps distribute heat and energy across our globe. Without thermohaline circulation, our polar areas would be much colder and different climates would be affected. An example is Northern Europe near the UK experiences a pretty wet, warm climate, but without thermohaline circulation, it would be much colder. Furthermore, thermohaline circulation helps to distribute oxygen and nutrients to deep water organisms, and it helps to also store carbon dioxide. However, there is a slight issue occurring. Scientists are currently trying to measure the speed of the thermohaline circulation, which is pretty slow. However, scientists have found that the circulation might be slowing down, and some predict that circulation could completely stop in the future. This would alter our climate completely and bring some detrimental effects. Climate change causes this slowdown of thermohaline circulation because as temperatures warm, sea ice isn't able to form or it's melted, thereby decreasing the salinity of surrounding seawaters and preventing crucial spots like Greenland and Antarctica from forming these sinking water masses. So the whole start of the cycle could be prevented if temperatures continue to warm. Additionally, Europe could be cooled, as I mentioned, if the thermohaline circulation were to slow down even more. According to Roger Williams University, northern water near Greenland that sinks helps to direct and pull surface water towards northern Europe, bringing the Gulf Stream, a very important warm surface current, towards countries like the UK. If the water isn't able to sink, the Gulf Stream could weaken and wouldn't be as strong and wouldn't be pulled towards northern Europe with the same magnitude that it had before, and therefore it would fail to bring as much heat to Europe, causing some cooling. So to recap, the thermohaline circulation is driven by temperature and salinity, which then affect the density of water. Thermohaline circulation is a very important natural ocean process that helps to regulate our climate and store important things like nutrients and carbon dioxide and also oxygen. Without it, we can see many negative consequences, and there still has to be a lot of research done to completely understand the process and to understand how climate change is truly impacting the thermohaline circulation. Thank you so much for watching this episode, and I hope to see you all next time. Bye-bye!